Okay, so for this, I'm also just going to make some random file. I'm going to call it or some random folder. I'll say promises practice. I'll go in there. So I'll just open it up. And at that point, I can make some random file, example.js. I just want to make sure I can run it. Great. So the thing about promises is that you can practice them without having to explicitly make a backend call, right? So you can make a backend call, and when you're on the front end, you might say axios.get, and then you say www.mywebsite.com. Maybe it's an API, so /user/44. And then at that point, you would say like .then, and you would do something with the response, and you do that in this callback function, whatever it is. Like when it comes back, just print out the response. Well, that's definitely a way you can work with promises, but something we can do is we can like mock promises. So if I look in promise itself, I can say promise dot, and I'll see there's all this stuff in there, promise.all settled. But there's actually some stuff in here like resolve and reject. So in that case, I can basically pretend I did something, and that's helpful for practicing things. So if I say promise dot resolve for, that's essentially just a made up promise that, it says if I made a backend call, as if it came back with the value 4. And then in my .then, I might say, okay, what was my response? Console.log that response. So let's see that. This one's not going to work because I don't have Axios around. But let's see our example version working, and maybe I'll do it like this. Okay. Didn't like that. Why not? Is it not in the right place? Yeah. Promises practice. Let's try that again. Great. So that's if I use promises.resolve, that's just as if I actually called some thing that took time, and it's still asynchronous, but when it comes back, and this will just always resolve, that's what happens. And similarly, I could say promise.reject, and in that case, it wouldn't do the .then. I like to make some space for these, but it would do the .catch. So the .then happens when the thing comes through successfully, and that's called resolve. If the thing does not come through successfully, if it fails, we call that reject. And same thing, I would say error there. And then maybe I would do console.error to see it in a different color, and I'll print that error. So let's try that. So it's still just showing 4, but I don't know. I don't know a great way to, because it's like the same color here. Maybe, I could just add some stuff where I say resolved with, and in this one I could say rejected with. So now we will see that if I ran this again, it rejected with 4. Whereas if I did resolve, that would be resolved with 4. And so that's going to be a nice way to test whether a given promise works or not. And so I could just have these like dummy promises to work with, like, I could as simple as say like promise.resolve or promise.reject. And then I could just, say, okay, I'm working with this promise, or I'm working with that promise. So is there something specific we want to see about promises? Because there are a fair amount of, depending on what you're trying to accomplish, there's lots of, features to this small little API. Like, what's an example use case you might be curious about with promises? Because this is the basic use case, which is we have a promise that, in the real world would be like axios.get, and it returns this thing called a promise object. And promises can either resolve or reject. And once they resolve or reject, it's done. So if we made a web request, if it was a 200, that would be resolve. And the response would be, the response containing the data. If it rejected, that means like it failed. Maybe it timed out. Maybe it was a 404. Maybe it was a 500 error. And then that means it rejected. And once it's in one of those two states, it's done. So that's an important point. A promise can't, it starts in the state of pending, and then either it gets resolved or it gets rejected. And once it's in that state, it's done. It's fulfilled. It's not going to be run again. So these are the basic two states. If it's resolved, the dot then happens. If it is rejected, the dot catch happens. And then there's one final thing we can call dot finally, and that happens regardless. And that's why it doesn't take anything, because it's not, oh, in this case, we get, this could have been 4 and this could have been like 8. And it could be anything. It could be any sort of data. The dot finally happens no matter what. I guess this doesn't matter here, so I'll do that. Which just says this always happens after either. And if we were to run that, we would see, what doesn't it like? Anyone know where this went wrong? Unhandled promise rejection. Oh, I think it's mad that like rejects 4 is just hanging out there. Okay, that's fine. I mean, we can let it be mad. And then, but yeah, let's just see that again. In the resolves 4 case, it resolved with 4, and then this always happens. You can ignore that error. That error will go away if I don't mess with that. So. And then probably the same thing. It's not going to like it if I just have a resolve promise I never handle. In this case, it will reject with 8, but this always happens after either. So this dot then dot catch dot finally is the essential API of promises. And if you know it's going to be successful, you obviously don't, because maybe the server doesn't even exist, maybe the whole internet's out. So you do generally want to have both of these. But if you know it's going to be successful, it's okay to just have a dot then. If you think there's a chance it's going to error and you want to handle that, you want to have a dot catch. And then dot finally is really optional, but sometimes that's useful for like cleanup type logic. So, like in the case of calling a web request, maybe you want to update your page before you do anything to say we're in a loading state. And dot finally is where you want to say we're no longer in a loading state, because whether it came back successfully or it got rejected, the loading state ends, and you don't necessarily want to keep that logic separately in the dot then and the dot catch. So the dot finally is for things that happen no matter what at the end.
Okay. Yeah, I think I was just confused on what a promise was.
You're asking what a promise is?
No, I mean I'm good now after you explained it. I was just very confused at what a promise was and what was all this extra stuff that came with it. But okay.
Ben, if I understand promise, right? Promise is an object that has a finally block at the very end, which is embedded in the catch, embedded into then, embedded into the reject, embedded into promise. Right. So it's like this quadruple, if not 5-layer call for a finally function at the end. Is that correct?
Well, if what you're saying is it's layered in the sense that this is a single object and we're calling dot then, like we're dot then is basically, it's a method on this object. And then we say dot catch because dot then not only modifies this object, it returns the object. So we're able to chain it. We say dot catch. And what we're doing here is we're setting up logic that the object knows about because it's that object that's responsible for reacting when something happens. Because if I, after this, wrote console.log, I happen immediately, even though we set these up, they don't happen right away because who knows how long it takes for it to resolve or reject. This is like a dummy example. It'll happen, more or less right away. But actually, even with this, I'm assuming the nature of the resolve and the reject is it's still async, which means this will happen first. And only once there's nothing left, this will happen. So let me actually run that to see.
So I could write this whole thing as the, rejects 4 equals promise dot reject 8. Then I could say, I can essentially break this whole thing down into variables, right? Or give them all variables. And then kind of, so because like you said, it's the rejects 4 is a response for promise reject 8. Then is a response to a reject 4. And then catch is a response to a reject 4 dot then. So I think I had the hardest time of understanding that this was a layered object and I could break it up in multiple little objects.
Well, you could, but the thing to recognize is that just like with arrays or objects, you would just be changing the name of it. So if I said like, let's say I'm going to call this my promise. And then I were to say const my promise 2 is equal to my promise, dot then some whole thing.
As a function, right?
But my promise 2 is the same as my promise 1. All the dot then is doing is modifying my promise, but my promise it is then returned from this. So my promise 2 is going to be the same promise as my promise. And then we could do that again. We could say my promise 3 is equal to whatever 2 was. And then we add the dot catch onto there. But you see what I'm saying? It's the same. My promise 2 is going to take what it currently is. It's going to call this function. But because this function knows this is like a pattern, we call this object chaining. Not only is it going to modify my promise 2, it's actually at the end of that function going to return my promise 2. In the actual object, like class logic, it's going to return this. So it's just returning itself for the sake of promising. So there's really no reason to rename them like this.
Yeah. Okay. Yeah. Perfect. Thank you very much. That makes sense.
Yeah. And so to make it easier to read, you end up seeing something like this more often where you're just chaining them. Something that might help us understand this even more. This is something you rarely do because Axios is doing it for you. Whatever library is working with promises tends to do this for you. But you can actually create your own promise. And that's a little, that like the resolve and the reject is just like a quick helper function. But if I made my own promise, like I'm going to say, my promise, and I'll replace this in a second, and then I'll call all of this on my promise, right? And then I could actually see what a promise is. So just like any other object, I would say new promise. And opening this up, okay, what does a promise take? This is where it gets a little confusing. A promise takes a single function. That single function takes 2 arguments. One is called resolve, one is called reject. And then from there, you call resolve or reject. So if I were to say, just resolve 4, this would work like it did before in the resolve case. If I were to say reject 8, that would work like the reject case. But in reality, we would probably do something more complex. So if we wanted to mock it being a backend thing, we would say something like set timeout. And set timeout takes like a callback function. So, this is the main reason for promises, that otherwise you're doing callback functions, and it's like callback functions. And that is sometimes termed callback hell, because it gets so nested, it becomes very hard to follow. But I'm going to make this set timeout, and whatever I'm going to do in 4 seconds. So in that case, maybe I'll say, okay, in 4 seconds, resolve with 4. Let's see that. So that happens immediately. Then we wait 4 seconds, and then it happens. Let's make it 2 seconds, because 4 seconds is a long time, as it turns out. In this case, I'm going to say, okay, after 2 seconds, reject with 8. Happens immediately because it's down here. And then after 2 seconds, we reject with 8. And now if we want to make this like a real thing, we might introduce some randomness. So we would say, like, does anyone remember what is how do you do random numbers in
random.randint?
Rand int, like that?
Yeah, I don't know if that I is capitalized or not.
Okay. Might have
And
to
then,
look.
yeah, in parentheses, it should be from what number to what number. Also, you have to import it, I believe.
I have to import it. That's why. Okay. So just import random from, and that won't work either because we're just in Node. So I'd say something like const random equals require. This require thing is just because Node doesn't, it's stupid. Modern front-end JavaScript, which is where you're going to mostly doing it, is where you do that import syntax. Node doesn't support that yet. So I get this from like random or something.
I don't know if JavaScript has this. I know Python has it, which is why I'm confused right now that you're trying to do it.
Well, JavaScript definitely has something like it. So if I were to look at, Node random, it's definitely in there somewhere. Math.random, that's what we want. Okay, so math.random is going to give us a random number between 0 and 1, I believe, and that's enough to do anything. So we have that built in. I can just say math.random. That's going to give us a random number between 0 and 1. So then I might say, like, if my random number between 0 and 1 is less than 0.5, then I'm going to want to reject with 8. Otherwise, let me resolve with 4. And this is now closer to a real, like, it's obviously still being mocked, but now I have my own promise. It takes 2 seconds to resolve. So that's like talking to some kind of server or something. It takes time. Then there's some randomness. It could fail. Someone asked something?
Sorry. Are you able to zoom out just a little bit?
Yes.
Thank you.
As in, because you want to see more of this? What zoom out because what, like that?
Sorry, I didn't realize I was still muted. Yeah, just so it's a little bit more visible if everyone else can still see it that way.
Is this good for people? Okay.
Yeah, that's better. Thanks.
So to reiterate, you're almost never going to write a promise yourself. It's always some library you're using that returns a promise. But this is what it's doing, essentially. I mean, the 2000 seconds is usually not made up. It's usually we're talking to something. It takes time. But the idea is something is going to happen. And in response, using some kind of callback situation, we're going to resolve or reject. It's one or the other. And in this case, I'm adding some randomness to it to say sometimes it does one thing, sometimes it does the other. So if I were to run this, let's see. So I'm going to say that happens immediately after 2 seconds. Oh, it rejected. Let me try it again. This time it resolved. So that's more like a real thing. And that's why you might have these multiple scenarios, because you don't know if it's going to resolve or reject. You have to handle both situations.
Hey Ben, I had a question. Can you just go over like where like what the purpose of like 4 and 8? I didn't quite get where like 4 and 8 is coming from.
Oh,
I know you
right.
passed it in, but
It's coming from, I mean, that's just basically 4 and 8 don't really matter. It's just what's going to be filled into response or errors. So if you resolve whatever you passed into resolve, that's what the value of response is going to be. If you reject whatever you pass into reject, that's what is going to be passed in here. So in reality, these would probably be longer objects. That would be something like, code 200. Oh no, that's my reject. So code 404, error message, not found. And then the resolve case maybe would be code 200, data, and maybe it's like a whole HTML page or something. Who knows? Who knows what you requested? And so in that case, you'd have these two situations where you'd say, oh, I got my response. Okay, resolved with, and then I'd say like, maybe I'll print out the code and then I'll also print out the data just to see it. Sorry, that would be like response.code, response.data because it's an object. And in this case, I might say rejected with response.code and response.error message because they don't, the reject and the resolve case they don't have to return data that's anything like each other. And they usually won't, because if you got data, you'd probably want to show that. Whereas if you got an error, you probably just want to share something like that. So now if I run this, I'll see like, okay, in the first example, it didn't like that. Why not? Oh, error, right. I called it error. Let's try that one more time. So we'll wait 2 seconds. Okay, it rejected with a code of 404 and the message not found. Let's try that again to see if we can get it to resolve. One more time. That's randomness for you. What are you going to do? There we go. So we resolve this time with a 200, and obviously that's not a great HTML page. It's not a great user experience to see nothing, but that is an HTML page. So it's just what you're passing into resolve and reject is just what you're going to get at the end that actually handles the promise. So here I'm creating the promise. You almost never do this. Axios would essentially do this for you. It would make the request for the URL you gave it, and it would resolve if it got, the data back. It would reject if it got back some kind of error. And then where you handle it, this is what you do, right? The part you handle, you say .then, .catch, .finally. The .then will happen if it resolved, and response will get whatever data was passed into resolve. .catch will trigger if it was rejected, and error will, which I can name anything. I can name this response too if I really wanted, but we tend to name it something else. That'll get the data passed into the reject case. Okay, so how do we feel about this? Do we we got 15 minutes until, well, basically I want to give you guys a little break before we start the new lecture. So do we feel good on this little promises session right now? Anyone have specific questions? Because promises are a thing you could dig into all day. It turns out there's lots and lots of cases where, if I want a situation where I say, I do something, and then based on what I did, I do something else, and based on what I did, I do something else. And if the first one errors out, I want to do this, but if the third one errors out, I want to do something else. Like there's all sorts of weird situations you can get into if you have, very specific logic, and the bigger a company gets, the more this becomes a thing. And then, there's even more sophisticated tools than promises if it gets really complex. Like I know Netflix is a big fan of using this, like even more advanced version of promises called, the library is called RxJS. I'm only showing this to you because it's interesting. So few people understand RxJS that outside of Netflix, just about nobody uses it. But it's like promises on steroids. So what's like an example? You have to use these like marble diagrams. Let's see, do we have any marble diagrams here? Do we see that word anywhere? Marble testing? No. Let's see, RxJS, marble.
Hey Ben, I had a quick question.
Yeah.
On the React.dev site, they use dot like .js files. But I know we're using .jsx files. Does it really matter? Because it seems like it works on both file types.
You're saying when we do front end stuff?
Yeah.
Yeah, so I don't think it does matter. One thing to note is, first off, file extensions are meaningless to something running a program. File extensions are only useful for your operating system to say, oh, I know that file extension probably means I want to open it with this program. Or, you know, for Visual Studio Code, it's going to say, oh, they opened the .js file. Let me do syntax highlighting as if it's JavaScript. Whereas if they open a .jsx file, oh, I'm also going to have syntax highlighting for that. I believe that Vite by default is going to pick up .js, .jsx. Yeah. And I bet if I looked in here and I looked at, you know, a specific, like, that's the kind of thing I bet Vite config takes some config to say like matcher. Because if you wanted to, for whatever reason, you said my file extension is .xyz, it's probably not going to pick that up, but you probably could somewhere in the config say, you know what, my JavaScript files, they end with .xyz. So make sure you pick that up. But file extensions are ultimately not something the programs really care about. It's only helpful for programs to essentially guess what you want to do with that file.
Gotcha.
Yeah, but just to show that, maybe if I were to rename this, can I do that here? I'm going to rename example.js to example, right? I didn't give it a file extension, or I could give it the file extension just total. Well, it's not going to like the slash probably. Total nonsense, right? That's the name of my file now. Lots of dots, lots of this and that. Node does not care. It's still the same file as far as Node cares. The only difference is like if you were to not have Node installed and you were on like Windows or something, and you were going to double click this file, if it had a .js at the end, Windows might be smart enough to say, hey, maybe you want to download Node. You don't have a program that can run this. This is a program I know that runs .js files. Whereas if you name it this, it's going to say, I've never seen that file extension in my life, so I have no idea what program opens that.
Gotcha. Thank you.
Cool.
And one last question, Ben, before we started this, you mentioned that this was asynchronous.
Mm-hmm.
When I was looking through the recordings of yesterday, I thought to make it asynchronous, we had to like make a whole different function, call that function asynchronous, and then call that function afterwards once it was made.
Right. So there's a slight difference there. Async await is a keyword. That's a pair of keywords that let you work with asynchronous code in a nicer way, in a way that like the syntax makes a little easier to work with. So when you're writing the word async, that's the async await pattern. When I say that this is async, I'm saying that essentially there's certain functions in JavaScript that are special and that they don't get run right away. So console.log, that gets run immediately. Whereas when I create a promise, and then also when I call something like set timeout, we noticed that even when I was resolving or rejecting immediately, this happened first and then this happened. And that's because a promise counts as async. It's something, by async, we mean essentially it's not executed right away, it's registered, and then we keep moving on to the program. And then when it gets resolved or rejected or whatever it is, in the case of set timeout, when the timer runs out, that's when it happens. And right, it's a little confusing because most languages don't have this concept of async, and it's also hard to tell what isn't async because it doesn't say it anywhere. Like, why would you know set timeout is an async function and console.log isn't? You just have to learn over time, I guess. But that is something to note, that like, even if I made set timeout 0 here, so I'm saying do this after 0 milliseconds, you might think because it's 0 milliseconds, this should happen first, right? But that's not actually the case. I happen immediately always happens immediately. This didn't wait 2 seconds, it waited 0 milliseconds, but the synchronous stuff happens first, because when we do my promise here, we're saying do this when it resolves, and this will resolve after 0 milliseconds. But by the nature of the async stuff, it won't happen until all the synchronous stuff is done running. So yeah, async is just stuff that you have to wait on, that JavaScript doesn't wait for it to finish. It just keeps moving. And it only, when you hit it, all it does is register it as like, when this gets responded to, and when I'm done running everything else, that's when I run that code.
So when do we need to actually specify async await? Like,
only when you want to write. So in the case of like my promise here, right? Let's just say I first wrap this in a function. I say call my promise, and I'm making a function there just so I can do this. So I'm going to call my promise, and then I actually have to call it. Call my promise, and that is going to happen just like it did a second ago. Okay, let's add those 2 seconds back in there. What was that?
So,
Someone said something.
yeah, can you put that console log inside the for loop just to see how long does it take the prompts just pop up? Like, if
Put the
it can
console log where?
inside the for loop.
The for
Like,
loop?
Yeah.
What for loop?
No, I mean just create the for loop and wrap the console log. Like, does it happen like between that thing, or it just waits until the for loop completes?
I'm not sure what you mean. What am I doing with the for loop?
Just iterate through the console log like 10, 20 times, and it just see, does it happen between the console logs, or as soon as it gets resolved, or it just waits until
You want me to do something like this? Just, okay. And then I want a console.log in there.
Yep.
And then you're asking when what happens in relation to what?
Does it wait till the last element, the 10th element, or it's going to happen between?
Yeah, no, that's a great question. So for is synchronous, like most things in the language. Console.log is synchronous. All 10 of these are going to happen. And only when it hits this point of end of file does it start saying, hey, what's been registered to run, eventually, in terms of the async stuff, and then async happens. So if we ran this, and let's say I happen immediately, so that we could see it. If we run this, that all happens immediately, and then the promise happens, because it was, we waited 2 seconds. If we waited 0 milliseconds, it's still going to be in that order. It just happened immediately. So async stuff only happens after the synchronous stuff has happened.
Okay. All right, thanks.
Oh yeah, right. I just wanted to show the async await stuff. So here we're calling, we can get rid of this for now. Here we're calling call my promise. So the only time I have to use the keyword async is like this. I say async, and I can only add it to a function. So now that I've added it to a function, it means inside of here, I have this keyword await. So I didn't change anything about the function. I just added the keyword async, and that gives me access to the keyword await. The cool thing about that is now I don't have to work with my promises like this. Now I can say something like const response equals await. my promise. And so this is actually all async await does. It breaks up a promise with the dot then, the dot catches, and it lets you write it in a slightly more readable way, where instead of saying, you know, my promise dot then, instead we're saying response equals await. And then I can now here work with response as, you know, but I'm not having to like nest in this way. And we'll comment this out for now, assuming that we can do it successfully. But that's the main point of async await, just to break it up like that. And that's what we would call syntax sugar. It's prettier, it's sweeter, right? But it didn't give you anything new. It's basically just helping you by taking code in one form and changing it to code in what would have been an uglier form, but you don't need to see it in that uglier form. So really behind the scenes, that's all this is doing. It's eventually taking out the async, taking out the await, turning it into my promise dot then, you know, parentheses response body console.log. And then of course, if we wanted to handle the dot catch, now it gets complicated again. We have to use try catch. And we would do that like try catch error. And now this could go in there. And then finally, and this could go in there. And that's all async await is going to do for you. It's going to change what looks like this into that promise we just saw. And it's really up to you if you like one pattern more than the other. But now this will work as expected. Let's try that out. We wait 2 seconds. It rejected. Yeah. How's that looking?
That helps. Thank you.
Cool. So I feel like we've done enough promises now. This is good that we have this on video. We're going to break now. Let's say we'll break for 10 minutes. So we'll come back at 9:37. I'll warn you up front. This is the most, this is kind of the toughest lecture that we do in React stuff. Because what we encounter today, I guess, let's just quickly show that in the next 3 minutes. Where are we going with this? Well, here are some examples I have. Let me open up one of those examples. Sorry for jumping around so much. Let me open up one of those examples. So here's what we're building towards. If I go to uniform curriculum, 7, day 4, examples, what is it? I guess we'll say React Router example project. That's probably what it is. Let me just see if I have my stuff in there. Okay. Don't worry about the code yet. Let's just see this running. Okay, let me move this over here. Yeah, so what are we actually building towards? What we're building towards is that I have like a really simple site here, but if I click on this, I go home. Okay, we're seeing a home page about. I jumped to the about page. It says about now. Didn't do any kind of refreshing. I didn't talk to the server. This is a React app that is now also, you know, URL aware and can update the URL. But if I look in the network tab, I refresh. I guess I'll do all, so I'll refresh. I am grabbing a lot of stuff initially, but every time I click one of these, I'm not grabbing anything new. So I'm actually able to, or in some cases, I'm grabbing some new, you know, images or stuff like that, because I might make some backend call, or I might talk to like a third-party API. But the idea is that I'm not grabbing a brand new page and having to talk to the server every time I click on a link. So I'm still getting the functionality of a link. So unlike yesterday when we had like the details panel, you don't want everything to live on one page. You want to have this ability to have multiple pages, but you don't want, basically in React, it's kind of nicer to just have everything be one website and then the URL just like seemingly reacts. Whereas if I were to go to Hacker News, this is a just traditional website where when I click, and we can see this better with the network tab open. Let's refresh so we actually see it. So it got some stuff. Now, if I click submit, brand new page, right? And that's kind of frustrating. And even pages that look similar, so I'm on new, that actually, it happens really fast, but that's a reload going back to the server, getting probably very similar looking resources and re-rendering the whole thing. That is not necessary, or it's not it's a pattern that doesn't work so well with single page applications. And so that's what we're covering today, how you can get this behavior in React, where it looks like it has multiple pages, the URL updates as if it has multiple pages. But it really all is a single app you serve up once. And then, even if the user lost their internet connection between, after initially requesting it, they could click your links and it would still work because the whole page was gotten in the beginning. Cool, but let's give you guys a break and we're gonna come back in 10 minutes. All right, see
Hey
you
Ben,
all.
sorry about this morning. I missed muster, but I am here. Just
Yeah, no
about.
worries. I think someone vouched for you for having a reason. Let me go back into I'll stop sharing. And I will. Okay. So let's see where my screens are. Only want one open at a time. Let me just get that ready. Okay, here's where I'll open the projects, and this is today's curriculum doc. So there's a fair amount of stuff to talk about here. The main thing we're going to be working with is React Router. Okay, so before we get into the logic of React Router, I think for this one, it is useful to talk about what we're building towards and see some examples. So the first thing we want to look at is this example of traditional server-side routing. So I'm going to open that up as a project, and there's some things here we want to note. So let's see that. Coming back here. Yeah, whoever asked in the chat, we are back. And I am recording. Correct, right? I'm recording. Let me make sure. Yeah, I'm recording. So I'm going to open up this project, traditional server-side routing. And we'll see that's, one of these standard index.html things. And we just have a bunch of links. So we link to the home page, we link to the about page, we link to the contact us page. Then we're including some file here, just some JavaScript file. And we're also including this index.css. I think we do that at the top. This is what a traditional website looks like, and we're going to serve it up with live server. So this is that site. And to tell the difference between the traditional approach and the approach we're going to see today, it's best to actually see it. And the way we see that is with the network tab. So I'm going to refresh and you'll see initially what happens. Well, here's a bunch of requests. And what happened is these requests went to my server, which in this case is, localhost 5500, and it got some file. And while looking at that file, it requested another file and it requested another file. And once it had all the files, we actually saw the page. So this is how most routing works, in that you request a file from a server, and that server is located at, localhost 5500. So that served up this home page. But what happens when I click about? I'm going to click about. Okay, you might have saw it happen really quick. The page refreshed, and then we actually requested all three of these pages again. We requested about HTML this time, which is actually a different page than the home page. So coming back here, we refresh that to see. It's just calling it this, but this is the index.html page. When we click about, we're actually loading a different page, but we're loading the same CSS and the same JavaScript. And if I click contact us, same deal. I load the index.css in the JavaScript again. But then I'm looking at this new page. And if we were to look inside, we would see, yep, we're requesting it from the backend. So now looking, I mean, it's a very simple site. It's just to demonstrate this idea of traditional server-side routing. So coming back here and looking at our site, we'll see that, you know, of course, the CSS and the JS, those files are being requested either way, they're the same file. So that's already kind of wasteful that every time we go to a different link, we grab these files, you know, from the server again. And if they're big files, that could take some time, not just to grab them, but also to read them. But also notice this, if I look at index.html, this is what it looks like. Contact us looks almost identical. About us looks almost identical. So if I click about, it's almost the same page. It has to have all this information in the head. It has to have this nav bar. The only thing that changed here is the value of this H2. So this is how, if you had a traditional website, like the way Hacker News works, every time someone clicks a link, they're going back to your server. They're going to a specific route, asking for a specific resource, because that's what a URL is, a universal resource locator. They're asking for a specific resource and they're getting it back, but that resource is almost identical to another resource. And it just is kind of wasteful. So coming back to what we're talking about here, right? We have 3 separate pages, but they're nearly identical in content. Every time we click a link, the browser has to outright refresh, and the network tab will show us that when we move to a new page, we're refetching and reevaluating the same assets. So that is how traditional server-side routing works. If you have any questions about that, let's pause for that, but that's what you've seen so far. Robert is asking, can you talk about the problem React Router solves? Yeah, we are going to see that right now. And we're also going to talk a little bit about this. You know, I have a little slideshow here to show the difference. So let's look now at what client-side routing looks like. So I'm going to have that exact same site, but now I'm doing it in with React, and I'm doing it in this client-side way. So coming back here, just note, this is what this website looked like. It was just a bunch of HTML pages and some assets that they all linked to, but it required things to be sort of copied a lot. So now I'm going to open up client-side routing. And you'll notice that this is now a React app, so it looks more like a traditional React app. If I go to app.js, I'm not using A tags anymore. I'm using this thing called link, which is a specific component we're getting from a specific library, React Router. We'll get into that a little more during today's lecture. That's mostly what it's about. And in package.json, you'll notice that we have a new dependency now, React Router DOM. So let's see what's different about this page. I'm going to serve it up. We're not going to look at the code yet. We just want to see what changed. Okay, so this is my site now compared to this one. So it looks pretty similar, right? Let's inspect. Look at the network tab, refresh. So the first thing that happened is that we requested a lot of stuff, and notice that, you know, all these pages, home page, about page, contact us page, we grabbed them right away. So we're doing a lot of work up front, but now we have the whole page. Now, notice what happens if I were to click about, the page changed, the URL changed, but there was no refresh and we didn't get any new resources. And that's because we grabbed everything initially. So what client-side routing is a way of saying, instead of going back to the server to get all of this, you know, to get a very similar page every time you click a link and then have to re-grab and evaluate the assets it relies on, like JavaScript and CSS, really all that's happening when I click a link is that it's going to render a different component. And so the page does change. It said home here, now it says about, but the URL also updates. So for your user, this still works like a website works. And if someone were to go directly to the, let's go to the contact us page, same deal. If someone were to go directly to slash, so going to slash, if I do something in the URL bar and I hit enter, that's always going to be server side. It's going to go all the way to the server to get the data. But the thing is, no matter what I put in here, it still goes to the right page. So it goes to the right page. And whenever it goes to that page, it's going to have to do that normal thing where it refreshes and it grabs all of this stuff. But that's only when I do stuff in the URL bar. If I just click around on my site, I'm not having to request any new resources or talk to the server ever again. And this is really why they're called single page applications, because even if it looks like you have multiple pages, it's all happening on a single page. And like, if I look at that example of that Jira clone, which this is the only way I know how to get to it. But if I go back to this Jira clone, we'll see, yeah, this one takes a fair amount of time to load the first time. So as you see, it's probably because it has a lot of resources. It takes a second to get started. Right, but this is like a pretty complex app. It can do all sorts of cool things. So some stuff happens in the background while I do that. But the cool thing is I can click on project settings. It's going to look like it goes to a different page. The URL is going to update. But nothing had to happen over here. And even cooler, like I can go like create issue or search, like I can modify the page in pretty significant ways. And the URL might change to match that. So the user can go directly there, or so that the user can like know what's going on. But we're not requesting any new data. And you couldn't do this in the traditional server-side routing way. Like the reason why this functions in the way an app does, the way Facebook works and things like that, is because I have this client-side routing. So it can respond to the user like it is a single application, and it's not like, whatever, news.y combinator, where when you click on a new thing, it really is a new page. It's not as good of a user experience. Like you can imagine I'm jumping between these pages. Why am I, reloading all this stuff when so much of it is the same? Just the content is the same. And then the other thing to note is that, let's look at it in the code. Last time we had these individual index.html pages, and they had to reuse all the data. Whereas in this case, we'll get into like how it's structured a little more, but app has most of the data, and app is always shown. And then when we click on these links, that's going to fill out this component called outlet. And what's unique to each page can just be contained to a single component. So we're not having to like recreate all that data in each one of these components. And that's good because let's say something changes that affects all the pages. I wouldn't want to have to do that. So like if I were to, let's say, add another route, let's say I have a route now called link other, just call it other. So this page doesn't exist right now, but basically if I had this, nav on each one of the pages, I would have to update this in 3 places. Now I just click save. I updated it in one place. And if I go back to my site, I now have this updated on all the pages. It's not going to go anywhere now because it's broken, and that's another thing. We get that nice little error thing if it doesn't find the page, as opposed to just, you can't find the page. So that is what we're building towards. So looking at my chat right now, Dennis is asking, is it like a whole big page every time, just show part of it? Yeah, essentially, the reason why they're called single page applications is because no matter what route you go to, you're getting the whole page And then the URL just determines what's actually shown on the page given a specific route. And Ivan, you're asking if the components loaded up front in an async matter. So components loaded up front. Well, anytime you're making a request, that is async. So getting all this information was async. But that doesn't mean that, Kelvin, what you're saying, if I understand, I believe is wrong. Kelvin being wrong, I know. But you're okay. So every time you're clicking one of these, when I click about, when I click home, I'm actually not making any new requests. It's because that they've all been requested up front. So it's just a matter of this library React router registering that you click something and then saying, oh, I guess they want a different component. What component's associated with that URL? Kelvin, you are right. So that's sort of a slightly different thing, which is in terms of YouTube making new requests depending on the query parameter. So it's still this, we get into this a little later in the lecture, but this is the part that makes this confusing for people, is that client-side routing is not an outright replacement for server-side routing. If some data only exists, like if you already have all the data, yeah, you can jump back and forth. But in the case of YouTube, they still want it to be a seamless single page application type experience. But they're probably going to have to, like, if you click on a specific YouTube video, even though the page doesn't have to completely refresh, the data for the video you just clicked on, it's not available. So like client side yet. So they need to make a backend request. And I guess they use the URL to make it clear what they're doing and to help themselves like communicate about it. But I mean, we could even do that right now. Like, let me go to YouTube, make sure that, okay, here we are, we're on, I don't know if you guys seen this. This is crazy, this song. This guy's so good. I don't know if you guys remember Paul Wall, but I'm a 2000s kid. This guy's nuts. Okay, so that's not what we're here for. Let's go into the network tab. So, right, we're going to refresh. So like you could see, YouTube grabs a lot, right? Still grabbing stuff. So let's say I wanted to click on, I shouldn't click on any of this stuff probably. But even when I scroll, it's doing stuff. But notice the page didn't refresh. So let's say I click on this video, what happens?
While there are many situations.
Okay. So the page didn't refresh, but they did update the URL, and the URL includes some data like these query parameters. So you might ask, why did they have to do that? They could have just done that in the background. Why include the query parameters at all? That's because if someone were to take this link and share it with someone, they want to make sure that if someone were to copy paste that link into the URL bar and hit enter, if you do the URL bar,
While there are many,
that's always going to go to the backend. And so this data is going to matter. So we get into that later in the lecture, but yeah, this is the confusing part of this, that client-side routing does not prevent you from having to have that page available on the backend and to have that URL match up to something. Because there's two ways someone can access a given part of your site. One way is they go directly to the URL in the URL bar. That is always going to be server side. You can't help that. Whereas if I click a specific thing, let's say I click my face here and then I click your channel, that actually didn't completely refresh the page. Most of the page, any resources we needed stayed the same. And then it just like updated the URL and updated what was on the page. This is my channel. You guys are gonna love my channel. 4 subscribers, things I did in college. Okay. Just looking at the chat right now. Roger, do people know? I learned about this guy yesterday, La Raza. Okay. So next thing we're going to do. So we just saw server side and client side routing. What are some of the things that change with client side? Well, one of them is that we could render the common parts only once, and then each page was just a component representing just what's unique to that page. The other thing is that we're not using a links anymore. We're using this component called link, and we'll see a little later why. But essentially that's because an A would do the server side routing. Link is aware of React Router because it's provided by React Router, so it will do the client side routing. And then we saw in the network tab, we weren't refetching things when we went to these different routes. So now I'm going to click this. You also have access to this. This is a slide deck. Okay. So this is hopefully going to help us understand the difference between client side and server side routing. I called it front end routing here. Doesn't really make a difference, but when I say server side, I mean back end. When I say client side, I mean front end. They're just two terms that mean the same thing. Okay, server side routing. So just to review, this is our traditional model of the internet. We have our server, which if we're the programmer, we're the company, we own the server. That's a computer we own. And then there's the client. The client is your user accessing your, who that wants to access some resource on your server on their computer. And there could be many, many clients. That client could be a browser. That client could be a cell phone. That client could be some Internet of thing that isn't, it's not even a screen. It's not even a person, right? But it's still a client. So you could have multiple clients accessing your server at the same time. Okay, so the client is going to make a request to the server. They're looking for, or really they're typing this into the browser, website.com. The browser figures out that website.com means your server. Your server gets a request. So this dotted line means the internet. And the client made a request. It got received by your server. Okay, on your server, you said, okay, they were looking for / that points to a specific resource, a specific HTML page. Let me give that back to them. Back to the client goes this HTML page, which probably has some CSS and JavaScript referenced in there as well. Client gets the HTML page, they start rendering it. Let's say on this rendered page, there's an A tag /about. They click it, right? They click this link. Boom, another request to the server. That's standard server-side routing. Now they're looking for a different resource, /about. /about matches another HTML page. That HTML page likely shares a lot of content with the page at / might share so much content that it's not just copy pasted, that you're, on the server side, you're using some kind of page generator where you're generating these HTML pages because they share so much content. Either way, you serve up a brand new HTML page, it's received, and it comes back with that CSS and JS reference. So now that it receives it, it has to re-render it. The HTML changed to some degree, so of course it has to re-render that, but the CSS and JavaScript might be identical, and yet not only do they have to be requested, they also need to be reevaluated. And if it's a lot of JavaScript or a lot of CSS, that actually takes time. Even though and why are you doing it? You just did it. It's the same data you already, that you had a second ago, but it's because when you refresh, you lose all of that. Server-side routing. Okay. So if a user puts a new URL into their browser, that's always server-side routing, grabs a new HTML page from whatever server is associated with that URL. When the user clicks one of these links, they make a new request to the server. So, they're not doing it in the URL bar. They're just clicking a link. But because it's a standard anchor tag, they go to this, they make a new request to the same server, but a different, path. They get a new response. It comes back. It refreshes the page. They reevaluate anything associated with that HTML page, including the CSS and JavaScript, and now they see the new page. So we consider this to be a limitation of server-side routing. That even if those pages share a lot, it's a hard refresh. It's treated like a new page. And even though I don't want to click this stuff, this is not how single page applications generally work. Whereas if you're on facebook.com and then you go to facebook.com/marketplace, you might have to request some new data using like, use effect, which is under the hood, ultimately Ajax, but you're not requesting a brand new page. The whole page doesn't refresh. It's only the parts that change that now, any new data you get, you might have to get new data, maybe all that was there initially, but now the page will look like Marketplace. That doesn't cause a refresh. So let's look at client-side routing conceptually. Client-side routing. So we're starting with the same situation, client server, internet, make a request. When you put something in the URL bar, you're always making a new server-side request because of course that doesn't yet exist on your client. It matches something. In this case, it's going to match our whole React project, which if we ran npm run build, it would be a single index.html page referencing a single CSS file and a single JavaScript file. That all comes back to the client. On the client side, we have our page, it renders, but because we're going to be using React Router, when it sees that slash initially, it says, oh, not only am I looking at the page, I'm looking at, specifically the route slash, so I'll render the home page. Then the user sees a link on the page, a link component to slash about. They click it. What happens? We don't make another call to the server. We stay on the client. We just change the URL. And because the URL changes, we change which component we're showing. So now we're showing about page, not home page. That's it. The benefit is that the entire site is returned on the initial browser fetch and then browser request. And then everything, all future navigation, as long as it doesn't need more data, that is just switching components. And that ends up being faster most of the time because you're not having to make this network request, which that's often not apparent, that is slow to make a network request when you're developing locally because the server and the client are literally on the same physical hardware. So it happens almost instantaneously. Whereas if I'm serving something and I live in America and all my clients are in Japan, who knows? That's going to take a fair amount of time every time they make the request, even if these people have great internet connections, because the server and the client are physically very distant. And even if they had fiber optic connections, direct wires, even light only moves so fast. And in fact, it's probably slower than that. So distance equals time. And the further away that server is from that client, the more time it's going to take. So you'd rather just do it all in that first initial request than have to do it every time someone clicks a page. However, it's not all benefits to client side. We couldn't talk about client side without talking about the main limitation, which is that when individual HTML pages are separated server side by different URLs, Google really loves that. Google has an easy time parsing those as different resources and associating them with different links. When your links are really different only because of, client-side routing, that is kind of all happening in the JavaScript world. Google's not as good at parsing that. And so client-side routing sometimes doesn't play well with SEO. So if one is really concerned with making sure that given some keywords or whatever it is, they're the top result on Google, sometimes they have to do some finicky stuff to get Google to recognize that URL is associated with a specific HTML page. But that's a pretty minor concern. And if you ever got to it because your company was super successful and you had to make sure that Google was able to parse this client-side routing stuff. It's possible, it's just not something we can talk about or introduce today. So right, that's our client-side versus server-side thing. And I went through that kind of fast, so we can go over it again if you want. Any questions about it? However, yeah. Anything we want to see? Kelvin's asking, does the server render the page for the user in server-side routing? Is there more upfront load with client-side routing? Does the server render the page for the user in server-side routing? So that's actually, this topic can get pretty complex pretty fast. So when something's served up from the server, normally it's just served up. Whether it's a React site or a site generated with React, or it's a traditional HTML, CSS, JavaScript site, all those resources are simply being served up to the client, and then the client does all the rendering. Yeah. Is there more upfront load? And so, right, that's another thing. There probably would be more upfront load with client-side routing because it's grabbing all the resources at once, as opposed to just the resources that one route needs. But part of your question about, does the server render the page for the user in server-side routing? So normally the server does not do any rendering of something like React. That all happens on the client. However, these problems have been thought about and solved by certain people. So if I go to Next.js, we don't teach this here, but Next.js is very popular as your go-to way to work with React in industry. It's going to have a feature in it called server-side rendering. I mean, if Mr. Beast is using it, if the Washington Post is using it, it's got to be good, right? So let's see if I can see that. Just I want to see server-side rendering. Okay. So it's not, let me see if I just Google server-side rendering. So basically there's a kind of best of both worlds once you're using certain technologies. I guess Vue does it as well. And the idea of it is that when someone makes a request to your server is going to be smart enough to say, oh, they're requesting this specific page. And I'm just going to render the React stuff for that page. And what I'm going to return them is like traditional HTML because I pre-rendered the app. It's probably not worth getting into the details of it. I wonder if there's a nice image to show what that is. So yeah, server-side rendering is going to be this idea that you're still going to make a request to the server. The server is actually going to render the HTML or the React for you and turn it into just HTML, CSS, JavaScript. So that's all it's giving back to the client. And it ends up being a kind of best of both worlds where you don't have any of the SEO issues. You don't have any of the slowdown issues. So stuff like this exists, but it's probably, as you see, like these are somewhat complicated diagrams. It's a bit out of scope for what we're talking about today, but these technologies exist out there. Okay, so any more questions about the basic idea of client-side versus server-side rendering? If not, I'm going to give us a little break, even though I know let's give us another small break. And then when we come back, we're going to really talk about React Router and how to use it. Just looking at the questions.
Hey, Ben, so I got kind of like see if I have it right. So normally we go to the server grabs what we want, we put the display on the screen. Now we're going to grab everything that we can get and then build like a little filter to just display parts of it.
Exactly. Yeah, that's basically it. So normally in that like first case, I believe this is my React site, right? No. Okay. Normally in that first case, every time we click on things, it's making a brand new request to the server. in this case, we made all the requests up front. And now, and the good thing about that is, let's say someone wanted to go to the homepage. Well, we made all the requests up front. It could be it's still making some of those requests while we're rendering the homepage. By the time they click on about, we have everything, and then it just goes there instantaneously. In this case, it's not until I click on about that I request those resources. And so the big difference is in the client side way, we're doing all the work up front, and then it's seamless to jump between pages. In the traditional way, we do only a little work up front, but that's because we're only seeing that one page. And then when we click on another page or a link to another page, we have to do some repeat work, and we have to do the work now that we otherwise in the client side way did up front. So it's not always the case that it's obvious which one is better, because it kind of depends. Like, it could be that you just want, the page to load as quickly as possible initially, or it could be that you have a case where the person you're working with is very far away, so you'd rather do everything up front, and then from that point on, it's a seamless experience. In reality, there's going to be these best of both worlds solutions, where you don't have to just choose one or the other. But the goal for today ultimately is not about like optimization or efficiency. It's just about saying, okay, up until now, our React pages really were just a single page. And if I wanted to show a details panel, I had to show it on the same exact page, right? And even if I made it so that when you clicked on the details panel, it showed a new page, it wouldn't work with the URL. It would be one URL for everything. And the downside to that is that someone might want to click on your URL, remember that part of the site, share it with someone, and then they want to be able to go directly there. So that's what client-side routing is going to solve for us. It's going to give us the ability to have multiple pages on our React site with different URLs representing different pages, closer to a traditional experience of having, a page with multiple links that go to multiple parts of the same site.
There, with client side, it's still connected and it's still calling back to the server, you said?
Yeah, so you can't get away from the fact that we talk about this later in the lecture, but if I go to a URL bar, anything I type in a URL bar and I hit enter, that's got to go to the server. It has no idea. Like, you'll actually notice with these 304 things, it's saying, okay, some of these resources, they actually were, I cached them, they've already been around. But if I do disable cache, do this again, it's got to get everything from the server. It doesn't know something's, so if you put something in a URL bar, you're saying to the browser, match this up with a server address, match this up with an IP address, go there and request the data. And then when you're done, come back to me and I'll render the data. Client side is only the part where now that I see the page, if I click contact us or I click about, the page changed, the URL changed, but I didn't make any requests back to the server. So the browser part, like if you hit enter, that's always going to be server side. Client side is just about having a more seamless experience within the view of your browser. So once you have the page, the fact that you can click around, see different things, see the URL update and response, state will also be maintained. So we'll see that later. Like normally, if you go to a new page, any state you had would be gone. It'll reset to the starting point. Whereas in this case, it's like my app is continuing to run. All the state will be maintained, but I get to jump to different pages and render that page and see it in the URL. Cool. Any other questions before we take a small break? I'm looking at the chat again. Islam John, I don't know what to tell you the golden balances, because we're like, that's a whole industry. Like Next.js's big feature that got them to be a major company was this thing, server-side rendering. So, you know, there's always room to find a golden balance. Yeah, and Robert, based on what you're asking, that's the goal of today's update to Video Store, that instead of just showing, you know, below your inventory, this details panel, now you're gonna have a details page. You're gonna be able to go to that page, see just what's on that page, and then be able to go back, like have a button to go back. And when you go back, you'll see the main page. And now it's separated by page, which is closer to what actual websites look like. Cool. Okay, we're going to break now because it's 10:20 almost. We're going to break till 10:30. When we come back, we'll start actually using React Router. Woo. Wait, you guys see my screen? Okay. Sorry about
You
that.
have to watch the music video again.
But it's temperature controlled, so it can heat and cool.
What's that sound? Is that you guys or me?
That was me. Did you have to
Okay,
watch
good.
the music video again?
Yeah, I was curious about it. It's good.
I had to watch it as well. so.
Yeah, it's great. Okay. So I lost track. Did I start recording again? I did. Great. Cool. Yeah, we're coming back. Jonathan, there's nothing to say damn about. I mean, you could say damn, but that's just, I mean, the personal project is assessment 5 because we just want to make sure, like, okay, you know, you have some basic understanding of the full picture, but it's not surprising that there would be some gaps in understanding because we move through this stuff relatively quickly. And yeah, I mean, there's, until you can see something from beginning to end, it's often confusing, like why you're doing what. And so we expect that personal project is going to be a time to notice and address some of these gaps. Okay, so for now, the rest of this class, we're going to be talking about React Router and what it provides us. So I do have this project and examples, React Router example project. But to see it, because I think you guys will appreciate that, let me actually do this in Vite, right? So I'm going to come here and I have a space set up for it. And I'll say npm create Vite, and I'll call this React Router example. Like normal, I'll choose React and I'll choose JavaScript, and there it is. So now I can go in here. And like always, first thing we want to do is npm install because it's starting with some stuff, although I think we're going to want to add things as well. Great. Now I'll open it up in VS Code. I'll do npm run dev to see my basic site. And there it is. I wish I had these separate. Yeah. I thought it would open this one, right? Okay, so this is that basic site, and I'll just start opening the dev console because I imagine we'll want to use it at some point. Yeah, Jesse, you're right. If all the other cohorts can do it, you can do it. And this is how boot camps work. Like I've seen this a million times now because I worked at other boot camps. There's an attrition rate in boot camps, but people make it a lot further than they would on their own in the same amount of time. So that whole thing where you're being pushed to go further than you really can is by design. Because you do make it further than you would make it if you were like, I want to fully understand this before moving on. But of course, there's going to be these gaps, and you can fill those gaps as you go. Some of them you'll be filling, you know, once you have a job, because we can't teach you everything. And your first job may well use a technology that we don't teach here. Almost certainly will. Okay, so here's my basic Vite app. And like always, I'm going to want to just get rid of some stuff. So I'll leave all the assets and stuff, but basically I don't want any of this. Maybe I'll leave the use state there, right? So I just want to simplify my page a bit. So now I just have a page that looks like this. I like to move this up here. Okay, so here's my basic page. That's all it looks like right now, but it still works. Okay. So looking back at my docs for today, we created our project and we went in there and then we installed the existing dependencies, but I might want a few more dependencies. So if I look at my existing dependencies, package.json, we just start with React and React DOM, but I'm actually going to want to use this new thing now called React Router -DOM. That's what they call it. And so I'm going to do npm install. And I'm going to want to do save so that it actually shows up in the dependencies list. And the things I wanted, I think I said I do want Axios because I'm going to want to make requests at some point. And then I also want React-Router-DOM. And this is something you could do with npm install. You can give it multiple things to install at the same time, and it accepts that. So I'll hit enter and I'll wait a second. Great. So it got everything. Let's look at it. We have React DOM, we have Axios, and now we're going to be able to access those. And so I'm just going to start, put this to the side. I'm just going to start my server up again by doing npm run dev, because I only have to stop it for the sake of looking at those or downloading those dependencies. Okay, so what's next? We're running it just to make sure it's still running. There it is. Nothing should have changed, but I should have access in my code to those dependencies now. Okay, the first thing we're going to want to do is replace app with this code here. So I'm going to do that. I guess I'm getting rid of that use state thing. I won't need it for right now, but I'm just creating a basic nav bar here. Okay. So where am I? Going to app, going to replace this outright. Something like this. So we just have a basic component like normal. I guess I'll take this out as well. Like usual, we're just rendering app. App is the root of our app, right? And then if I look in app, I'm just returning some JSX. So I'm not doing anything else. Just gonna have an H1 and we're gonna have this nav bar. It's gonna have a list of things in the nav bar, and each one is going to be a standard anchor tag that links somewhere. So I'm gonna save that. I'll look at it. Okay, it looks kind of nuts, actually, probably because I want to take some CSS out. Let's do that, actually. I mean, I think this CSS we're including up here is doing me no favors right now. So I'm going to take it out. And I come back here. It's still, oh man, I kind of want to add something to make this. Let's see how we might actually do that. So looking at this UL, I might say, wow, those things are really bunched together. Wouldn't it be nice if I did some style stuff? So let's review that. If I start saying flex, okay, now I have access to this screen. And once I have access to this screen, I could say, yes, I do want them in a row. I don't want them in a column, although column's nice too. But I do want them in a row, but I want them maybe spaced out a little. So it looks like that's what I want. You know, there's a couple good ones. But let's say this is what I want it to look like. So I'm just going to do that. I'm going to add to these styles, let's say, to target that UL. So I'm just going to add those here. So that is being included. Or no, none of it's being included now. Let me go back. So not strictly necessary, but it would be nice if those things were spread out a little. And I believe this will do that. And I believe the issue with it before was I don't want everything in the center. So maybe I just take that out. Let's see what it looks like now. Okay, this is what I want my website to look like. Great. So I have these three links. I can click home, click about, I can click contact us. Notice they did change the URL, but we're just serving up the same page now because we haven't set much up. Just keeping up with the chat. Yeah, I'm copy pasting. So Roger, if you want to see it all done, it is there in that examples folder, but I'm copy pasting stuff from a blank thing so we could do it. I have to copy paste because if I didn't, I wouldn't have time to do all this, but we will review each thing. So right now, we're just rendering app. This is what app looks like. And it's just standard, JSX, HTML, just an H1, a nav, and some links. We haven't really hooked anything up yet. Okay, and if Roger gives me the thumbs up, that means we can move on. That doesn't hold for the rest of you. Roger has a special status. Like Ethan, give me the thumbs up. It means nothing to me. Roger, give me the thumbs up. Yeah, I'm just playing. Okay. Yeah, that means a lot. That really makes my day. Okay. So I'm just picking on you, Ethan. I'm joking. Okay, so here are my links. Ooh, he's giving me the gladiator thumbs down. Okay, so coming back to my example here. This is what my app looks like right now. Keep going. Okay, well, I want to make some pages because I want to display those pages uniquely in this situation, right? So that's going to take a minute. But yeah, let's make these pages. I'll just copy paste this one and then I'll modify each of them. So like usual, I kind of like to have a components folder. And in there, maybe I'll make something called, I think I called it homepage. So homepage.jsx, and this was the logic. Then I'm going to want to do that 2 more times, and one is going to be called about page. So for that one, we'll change it to something like about page, about me. And this one will change to contact. Let's call it contact page to make it simple. So personal email is no. Okay, so now I have these 3 pages, and maybe right now I'll just say, okay, coming back here, even though I haven't hooked them up yet, maybe I want to do something like this. I'm going to say import homepage. So I'll do that for all, or, maybe I'll just do the homepage right now. So, below this nav, I'm going to say, okay, well, here's my homepage, and that's what I'm displaying. Okay. So now what I have is this. I'm on the homepage, I'm displaying the homepage, but of course, if I click about, I click contact us, it's not doing anything right now. It's changing the URL, and notice it actually is a server side type change. So it's reloading the whole page. It's just happening quickly, but I'm always displaying the homepage because I haven't really hooked things up yet. So our first step is ultimately to set up React Router to start working with client-side routing. Okay, so our app, coming back here, we set up these pages. Okay, the next thing is kind of complex. We haven't seen this yet, and so I'm just going to copy paste it, but we will walk through it. Whoa. So I'm actually saying, let's go into the source folder and at the same level as app.jsx and main.jsx, because this isn't just a regular component, it's an important file. We're going to make something called router.jsx. Okay, so I'm going to come back here and I set at the same level as the rest of source. I'm going to say, let's make a new file and we're going to call it router.jsx. And router.jsx is going to represent the routes for all of our app. So here I'm actually requesting those components. I actually called this one contact page, right? So let me update that to make sure it knows about it. Yeah. So here are my 3 pages, and actually even app itself, I'm going to import in here because this router is kind of represent the new root element because it's going to represent my whole page. And then I imported this new thing from React Router DOM called Create Browser Router. So React Router DOM provides a few different kinds of routers. I believe we use one later with Francisco during the deployment phase. I'm not sure what route he's going to go with that route. But we're going to be using this thing called Create Browser Router, which is like the default, it's the normal one. And note that we're not creating a component here. All we're doing is creating an object here. So ultimately we're exporting this thing called router, and I create that over here. And what that is I'm going to call this function I got, create browser router. It's going to take a single input, which we see here, and it's going to create this router object. So let's look at how we define our route. So first, the whole thing, it's easy to forget, the whole thing is going to be in a single array. But notice I only have one object in the array. So the reason for that is because ultimately it's an array because I could have a bunch of pages that are totally unrelated to each other. As it turns out, that's not how my app works. Instead, I only have one thing. I only have one page I'm representing, and it starts like this. I say on path slash show me element app. Okay. And for right now, let's imagine this isn't here. So I'm saying on path slash show me element app. And I could have just as well said, you know what, actually on path, slash home, I want you to show me element homepage. And in that case, I'd be saying app is completely separate from homepage. They share nothing in common. But that's not what I want to do. Instead, what I want to say is something like this. I'm going to go back to how it was, and I say children. Okay. So what I'm saying here is path slash is associated with element app. So on I'm at slash show me app. And so it's going to show all of this. But I'm also going to say, well, path slash with element app has children. Who are those children? Well, index true, element homepage. So when I'm truly at slash, show me the homepage. But when I'm at slash about, still show the whole app, but also show the about page. When I'm at path slash contact us, still show everything in app, also show the contact us page. And we'll see how we get that to happen, how we show this, but then we also show what's in here. So that is the structure I want my app to have, where looking back here, I always want to show all this because app represents the title and it represents the nav bar. But then depending on which page I'm on, I want to show a different value here, which we haven't quite set up yet, but that's what we're building towards. So before moving on, because this is kind of a big one, what questions do we have here about this router object, which at the end of the day is just going to be an object. So we could even see that perhaps if I were to print that out over here, console.log router. Well, I don't think anything's going to print out until I include it. But it's just going to be an object. So let me go to, I'm going to be foreshadowing something. What I'm going to do here is also import router like that. Okay, so now that I'm actually importing it, this file should actually get run. And when it gets run, at the end of it, I'm actually going to print it out. So now going back to my console, let me actually see what happened. With console. Okay, so this is my router object. I don't really understand it, but it's just an object. And you'll see it has functions like navigate, other things, base name, slash, okay, routes. So it has some information in there that, is going to be used to go to these various pages, but then there's a bunch of stuff in there that I don't quite understand. Just as a helpful tip, whenever working with JavaScript doesn't have the idea of private variables. So if you ever see something with $, that's essentially the creator of the library saying, please don't touch this. Please don't modify this. You can. There's nothing in JavaScript that means you can't, but I don't want you to. And if you do, it's probably going to break the functionality of the app. So that's, if you see $, that's what they're trying to tell you.
Hey, Ben, how does the main JS know to go to the about JSX and not about CSS? I thought you said earlier that the JavaScript doesn't care about file extensions.
Right. So, well, nothing explicitly cares about file extensions, but part of what I said was they are useful for making, smart guesses. And so you're right that when I'm in main.jsx, for example, if I say /router, I didn't have to say /router JSX. I could, and that still works, but I didn't have to. Why? Why is because the fact that I'm in JavaScript, the fact that I'm using Vite, it's going to guess for us. So if you don't include the extension, it's going to say, I'm assuming you meant .js. I'm assuming you meant .jsx. That wasn't the case for the CSS, though. If I said /index here, it would say probably, let's try that to actually see. We're probably going to get something saying, hey, I couldn't find anything called /index. So there we go. It's saying failed to resolve import /index. Does the file exist? And the problem is because it's looking for a file called .index.js or .jsx. So file extensions don't matter in terms of running something, but they are useful for programs to guess what you're looking for. And in all of these cases, well, for these are not relative because they represent a library, so it's a little different. But in this case, I could say .jsx, I could say app.jsx, and now it's going to work. And similarly, let's say I try to say .js. Well, I'm being explicit there. There is no file .app.js. And either I think it's Vite is smart enough to know that if I'm importing something and I'm not explicit about it, it means .js or .jsx or something else that it identifies as a valid, JavaScript extension.
Got it. Thank you.
Cool. So any other questions on router as we've seen it so far? We will come back to this once we get it functional. I guess maybe we should just wait until then.
I just have a quick question, Ben. I'm assuming that the index in the homepage one index is true is just because that's the one that's the first page you see when you start up the website, and then the rest of them are just paths to whatever information we're going to see when you click on that.
Exactly. So the reason why it's done that way is because here we have slash, and we would read this child as like, oh, that's going to match /about. And so if this had a child, it would look like children, maybe this itself had a subpage, and that might look like path, us. Oops. And then this, whatever, element this matched, let's just say whatever, some element, this would be read as /about/us. But for the case of the index, we could have theoretically written something like path empty string, but that's not so clear. And so the API that React Router DOM has chosen to use is to say, okay, well, when you're talking about what renders exactly at /, we're going to define that by index true, just so it's a little more clear than, empty string. I wonder if empty string would even work. For all I know, that actually works. Okay, so this is my router object. Coming back here, I'm going to look at the next step. So that / is going to match all of them because it's going to match anything that starts with / and then / for the index true is going to match homepage, /about page, /contact us, the contact page. But now this is new. We're actually, for the first time, going to update main.jsx. So normally we didn't touch it because normally the route of our project was app. But you'll notice here, things are going to change a little. So I'm just going to grab this one part here. So if I come back here, well, my router is aware of app, and it doesn't make sense anymore now that app is the root of our project. Instead, we want to give it a new root for our project. And in order to do that, I'm going to use this other thing that React Router DOM gives us called router provider. And you can probably see where this is going. I'm not rendering app as the root anymore. Now I'm rendering something called router provider. Let's make it look like that. Hopefully it lets me do it on more than one line. Okay, router provider though, it takes a prop. It needs this prop. The prop is called router, I believe. Yeah. And what we pass there is that object we define. So I could have actually defined my whole router in this same file. I just like to split it up. But it's that object we got from router.jsx, this object, that's now being provided to this component called router provider, which comes from React Router DOM. And that's the new root of our app. So let's click save. So now we've mostly set it up. This is the root of our app, this router provider. It gets this router object. That router object, it's aware of all the pages, and it's going to say, okay, /show app. And in that case, it'll work right now. So this is app still. This is what app looks like. Come back here. I'm going to refresh. I think I want to stop logging that. Okay, so now we have our homepage and it's working again, though not much has changed. But if we were to look at the elements, or I guess that's not going to have changed either. But if we look at the components, we'll actually see that top thing is a router provider. As you can see, like it's using context. That's what the top provider thing is. And there's a whole bunch it's doing that I don't really understand in order to make it all work. But finally, once we get here, we're actually showing our initial thing, app. And app renders homepage currently. Now, note that app is not rendering a homepage right now because we set it up correctly. Instead, by the nature of how we defined app. If I come back here, I see, okay, well, in main, I rendered this whole thing, which was coming from the router. In router, I said, anytime you're on /register app. And then I said on index register homepage, but we actually haven't integrated this part yet. We're going to see that in a second. So for right now, on /, we always render this whole thing. And this is explicitly calling homepage. And that's actually going to be true for all the links now, because we haven't really hooked up this part yet. So the way it works right now is no matter which page I click on, still doing that whole refresh and still showing this whole thing. Okay, so this is a lot to get us to the place of it basically working. Do we have any questions now, or should I keep going to get it to the basic state? Okay, well, that's now integrating this router provider as our root element. I see here I actually did that UL stuff to make it look right. Okay, so the first thing we want to do now to make this client side, so like up until now, what we've done is hook up React Router DOM, but we haven't made it quite work yet. So we want to make our routes client side aware, meaning we want to make it so that looking at this router object, when I'm on /, I do want to show app, but if I'm on exactly /, I also want to show the homepage. If I'm at exactly about, if I'm on /about, I want to show the about page /contact us, the contact us page. So coming back to app, I don't really want this. I don't want to always be showing homepage. I want to be showing the right page when I click on the thing. And it's almost like I want, maybe I'll make a paragraph here to show it, this is where the page goes based on the URL. So of course, that's just text right now, but how do I do that? How do I make it so that based on the URL I'm at, the right page is there? So that logic is already set up in router, but how do I make it happen? Well, that's another thing React Router DOM provides for us. So in here, I'm saying import, and what I'm importing is from React Router DOM, and it's going to be smart enough to know it. This thing called outlet. So outlet is going to represent that component associated with the child. So when I'm on slash, exactly slash, outlet will be replaced with homepage. When I'm on slash about, outlet will be replaced with about page. When I'm on slash contact us, outlet will be replaced with contact us page. So let's actually see that. Outlet is itself a component, and it's going to look like this. Cool. So now I believe we have things correctly hooked up. On the home page, this is what it looks like. On about page, on contact page. And if I clicked on contact us page and I went right there like this, that's still what I see. So now we've hooked it up so that depending on the link we click, the URL updates. And when the URL updates, the specific part of the page we want to update reflects that. So that's our first step. And yet notice that every time I click on one of these, it's outright refreshing. And we would see in the network tab, yeah, we're actually making all those new requests again. So that's the next thing for us to fix. And the way we fix, yeah.
That's how putting an outlet at the end of that works.
What was that?
How is outlet being put right outside the nav bar like working?
What do you mean by how is it working? As in,
you just call it outlet and it automatically links all that together?
Yeah, so that's why in main.jsx we're making this the root of everything. So I think the way this works is that this router provider takes that router object, and we don't need this anymore. And if I were to go back here and now I were to look at the component stuff, you'll see that router provider actually has a lot of stuff in it. And at some point, it's aware of, you know, all of our routes. We might even be able to click and see. I wonder, might not be so easy to see. But once we get to app is going to have something in it called outlet. Outlet is going to somehow know, because it's hooked up to React Router, which thing to replace it with. This is probably happening in this route.provider thing. We don't really need to know the details, but what it knows is that the child we care about right now is the contact page. So that is, you know, maybe a little bit of magic. But this router provider hooks up, you know, makes as the root of our project this thing that is aware of that router object. It's that router object that says when you're on slash, always show app. And then inside app, we have outlet, and outlet will get replaced through, you know, React Router with one of these, depending on updates to the URL. So yeah, it's a little bit of magic, but outlet is going to be replaced with something based on whatever is defined in router. Reasonable? Okay. And this happens as projects get bigger, as technology sort of builds on other technology. It can feel kind of magic-y, but you know, under the hood, this is all just React using stuff like context. So you could have done this yourself. It would just be complex, probably.
So, quick question. So,
Yeah.
like before, we were putting, you know, our components in our app. Like we would have our homepage in our app, and then the homepage would have whatever else. But now we're like throwing the outlet in there, and we're specifying all of what we were previously specifying as far as components goes in our app, but now we're doing it in the router.
Can you ask that again? I'm not sure.
I guess we're just we're specifying our components now, I guess just in the router as opposed to in the app. Yeah, I guess I don't know if that really made sense.
No, that did make sense. First of all, who's talking right now? Because I can't see. I'm assuming you're not on the screen, right?
That's Michael Lake.
Oh, okay. Hey, how's it going?
Good.
There we go, Michael Lake. Okay. Okay, so yes. Short answer, yes, that router, basically whatever we render here, that's the root of our app. And instead of it being app, if it was app would be the source of truth. Or app would be the first thing that renders, that has to render everything else. Instead, we do this because router provider takes router, and it's now going to be aware of everything. It's going to say, oh, when you're on that page, you want app/homepage. When you're on that other page, you want app/about page. It does all the hookup for you so that app can use outlet.
Yeah, I think, I mean, it makes sense at a surface level. But yeah, it's just gonna be something to get used to, I guess.
Yes. Yeah, it takes a little getting used to. But it does work, and I guess playing with it is the easiest way to see it work. But there's one thing we haven't done yet, which is that when we click on these links, we're still having to refresh and get all that, redoing everything. So we haven't quite achieved client-side routing. So there's one last step, which is, React Router provides us a lot of things. And one of them is called link. And link is going to replace our A tags because A just comes from regular HTML. It's going to make our request to a server associated with / our current, whatever we're currently on / whatever we're currently on / about. And that is not going to do client-side routing because it doesn't know about React Router. So instead we use this, which is going to allow us to know about React Router. And I guess to distinguish itself, it's uses a slightly different API, by which I mean, instead of using an attribute called href, it uses a prop called to. So now I'm going to save this. And now this is finally what we expect, where I got all these resources to begin with. I'm going to clear it, and we'll see that when I click around, it updates, no refresh. So that's the basic level we wanted to hit, and we hit it now. And that's going to be enough to do basic client-side routing. There's a fair amount of setup, like scaffolding type stuff there, but we finally got there. Okay. Yeah, I hear you, Ivan, in terms of keeping track of stuff. There's only so much I can do about that. The file name is here. But yeah, there's a lot of jumping around. And just like, when you do stuff yourself, you probably jump around a fair amount.
Yeah, totally. Yeah, no, I just, it's there. It's just, keeping focus on where we are, where we're located at. That's
yeah. And I'll try and, what's the word? I'll try and telegraph a bit more when I say, instead of just going boom, 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 I'm going to say, okay, now looking at the site. Okay, now looking back at the code. Okay, now looking back at the curriculum doc. That's the best I can really do.
Thanks, man.
Or we can require that everyone attending Code Platoon has 6 monitors, including me, and then we can really split it up. Okay, that was our outlet stuff. This was our link stuff. So we got the basic thing working. And now from this point on, we just want to talk about all these different solutions it gets us. So I'm going to go all the way to the top just to show us the things we want to do. There's kind of a bunch of things to do. We have like 50 minutes-ish left to class, and I would like to talk about the assignment a bit too. So there's a couple things we want to do that React Router is going to help us with. One of them is a 404 page. So for example, if I were to go back to my page here, and I were to go to something like localhost / random thing, we actually get a nice 404 page coming from React Router, but we can customize that. We can make it our own 404 page. We're going to want to see how to do that. Coming back to the doc, parameterize routes. We haven't seen this yet, and this is pretty useful. This is just like what you have on the back end. To come back to my site, I want to be able to say not just / the users page, but actually users 44. That doesn't work right now, but I would want it to be not just a common users page, but actually, oh, when you go to this page, I want to be aware of that parameter to, use it to get specific data. Coming back to the doc, programmatic redirect. So sometimes you're not going to just want to redirect because you clicked a button. Oh, sorry. Sometimes you're not going to want to redirect just because you clicked a link. Sometimes you're going to want it to be that you click a button, something happens, something else happens. Oh, if you're in a certain situation, you want to go to a specific page. So that's what this is going to get us. And you'll see that these things start with use because React Router is basically giving us its own hooks. And there's some ways of passing data around because, as you notice, the outlet is not its own component. Props won't quite work. So yeah, we're going to cover all that. I see the chat just blew up big time, but okay, it's talking about everyone having iPads or something. But yeah, let's give us another 5-minute break and come back. And when we come back, we'll just get as much of these as we can of the like useful features React Router buys us. All right, see everybody in 5 minutes. Okay, so yeah, let's start covering these different features we get with React Router. Coming back down here, a lot of this was just the setup. Okay, so one that's relatively simple. I'm just going to create this error element. So we're just going to create an actual element like this. So maybe I'll include it first. So coming back to my router, and router is often our new source of truth. So a lot of stuff happens there. I'm going to import another component and let me just create that component. I'll say, you know what, I'll copy an existing one. I'll say this one is called error 404 page. I believe that's what I just called it. And that's what I'll export. And I'll just say 404 not found. Okay, so that is what I'm grabbing over here. That is the same page. And of course, I could do something like this where I could say, if you go specifically to error, then we'll show the error 404 page. And like the other ones, this will work. I'm going to refresh. And I guess I'll do it like this. If I go directly to error, I see that 404 not found page. But because it's a 404 page, generally we wouldn't want to show the rest of the site at all. And so really, I don't want to show app and then show it as, a child of app. I would want it to be a separate thing. And so, I might say, okay, well, actually what I'm going to do here is, this represents the children. This represents that whole thing. Well, I could have another one here, like I mentioned. So maybe I'm saying, when someone goes to slash, that's what we show. When someone goes to slash error, all I show is the 404 page. So let's see that. Now, someone goes to slash, this is what they see. Now someone goes to slash error, this is what they see. So they're just seeing the 404 page. They're not seeing, the app stuff as well. But this isn't quite what I want, because what if someone goes to, page doesn't exist? Well, maybe even that. This page doesn't exist. So what happens there? Well, that still brings us to this classic 404 page that React Router was nice enough to provide for us. And, maybe we would want to make our own 404 page unique because it links back to some resource or something. So the solution for that here is that we don't do it this way. Instead, we have something like this. So we take this out and we say, okay, well, in here, I define path, element, children. Well, at the same level, there's going to be something called error element. Error element says if there was any trouble at slash. So when I'm trying to go to slash true, just slash will work, slash about will work, slash contact us will work. But if I do slash anything else, that's when I want to show my error 404 page. Comma. Okay. Now this will work like I expect, where if I go here, that works, about contact us works. But if I were to say contact us slash 303, that's not a real page we know about. So we see our 404 page. So
And
that's
the,
the big, go ahead.
I was gonna say in the docs, you got it down below the children. Does it matter where you place that at?
It does not. So like,
Okay.
there's nothing unique to React Router about this object we're creating. So this is just an object. And the nice thing about objects compared to like arrays is things are key value pairs. It doesn't care where this is because these keys don't have a particular order really. I mean, it could be first, right? It could be all the way at the end of children. It really depends on what's nice for your own organization. I guess because children is big, I thought, well, might as well put it up here so that we don't miss it. But it won't actually matter as far as functionality is concerned because this is an object. It's going to be able to see it any which way.
Gotcha.
Ben, can you show again? I'm sorry, Ben, can you show again how you made the Arrow 404 page without the nav bar?
Yeah, so in this case, it won't have a nav bar. This is the final solution, which is error element, error 404 page. This won't have a nav bar and it will match on any old, broken URL. But if you're saying, how do I get like a random page to not show this? Well, that's why if we come back here, Browser Router doesn't take an object, it takes a list of objects. And that's because all this stuff I did here was relative to slash, but I could have made a totally different page. I could say, okay, well, everything here is actually relative to home. And then the rest of these are going to be home about blah, blah, blah. So now if I come here and I say slash home, that's what I see. And if I say slash home slash about, that's what I see. But I can have an entirely separate page. So I could say, okay, well, actually there's another object. And this object is going to have a path of slash other. And that's going to show, any element. I mean, it could even be one of those same elements. It could be homepage, but this isn't going to also show the app stuff because I didn't do it in this way. I didn't say show the app and then a child of the app as homepage. So in this case, when we go to slash other, that's only going to show the content of homepage. So now here, come back here, go to slash other. That's all we see. Whereas when I went to slash home, that first looked at app, and then app has in it something called outlet, and outlet is hooked up to the matching child.
Got it. Thank you.
And now this is confused because I made it link to slash about, and that's not how it looks anymore. So I'm just going to put that back to how it was. And now this is right. Yeah, I want to, and this is the common pattern where you're going to have something at the root level, which is slash. You're going to show something always for that slash, and then you're going to have children of that slash. And it's only that error element that you wouldn't want to show any of app. Yeah, I keep looking at the chat because it grows and it's all monitor talk. Okay, so this still works like expected. Like there's been 3 things since I last checked. Yeah, it's monitor talk, Megadesk. Okay, coming back here, That's error element. That's cool. The next big thing we want to see is parameterized routes. Probably the most important thing here. You're going to need that for the assessment as well, because in the assessment, you're going to have these like Pokemon pages, but you want to go to a specific Pokemon page. And we're going to do that here with something called user page. And I'll make user page in a second, but first I'll just import it as if it already exists. Okay, so just like these other pages, I'm gonna have something called user page. Let me just make that quickly. It's called user page. User page. And for right now, I'll just say user. And how do I hook that up? Well, coming back to router, I have that user page. We're just gonna have another child. And the first thing I'll do is say, okay, that child is not going to be just slash, not going to be slash about, it's going to be slash user. And in that case, I show the user page, and we haven't introduced anything new yet. We just have another page we're showing on slash user. And maybe I'd come back to my app just to say, okay, let's also have a link to user, say user page. So I'll come back here. If I click on user page, this updates /user, we see the page user filled in as its child. So that works, but of course we want to be able to say something like user /44. Right now that's not going to work. That's going to bring us to this page because it doesn't know about it. So we have this feature on backend stuff, this idea of parameterized routes. How can we make this work on our front end? So looking back at our docs, we can have patterns like this. So we do colon, and I believe it's the same in Django. We'll do slash and then colon something, and then that's going to be something that we actually pass in. It's a wildcard. It's a variable. We're going to call that variable user ID, but it could be anything. So I'll come back here, go into router and say, okay, it's not just /user, it's /user colon, oops, colon ID. I'm just going to call it ID. Okay, so user's also going to get an ID. So now this is actually going to work. Like, let me come back to app. Maybe I'll say users /44. It's going to bring us to the user page now. And that will work where I'll come back here. I'll say user page. We actually went to the user page, but how do we grab that 44? That's the next part. So coming back here with router.js, we're done. All we have to do is say there's a path that looks like this and it has a wildcard in it. Now, from the user page, how do we access that parameter? Well, coming back to user page, React Router DOM gives us a bunch of things, including its own hooks. And one of them is called use params. So use params works perhaps like you would expect it to. We say use params, and then we wrap it in braces, and that's going to return us an object. That object is going to be the key value pairs of all of the params provided to this, but we only provided one. So I'm just going to destructure it right here. And I'm going to say we just want ID. I could have just as well called this like params. Like I could have said params and then reference it as params.id. But just like with React, sometimes it's useful to just say, well, there's only something on there I want called ID. Let me grab ID. And now I'll be able to say users and, actually display that specific ID. And this name ID, that's coming from here. It has to be the same name. So now coming back here, it actually knows users 44. And if I were to say 72, it knows user 72. And that's going to be useful because, you could use that number to maybe make a request. Like maybe when you get to the user page, you don't have all the user data. You have to talk to some backend, ask for that specific user. And that's how you might do that. And so if I come back to here, maybe this user page is really a pokey page. So in that case, I would say import use effect maybe. And yeah, let's do this together. How about let's make a use effect that's going to be aware of this ID to print some pokey page, right? We're probably going to want use state there too. So the first thing I'm going to want to do maybe is I'll say like I have a use state that keeps track of, pokey. I'll say pokey and set pokey. It'll be the whole object. And that'll be use state, and it'll start as null. There is none. And now we're going to want to write our use effect. So just like all the other parameters or all the other hooks, it has to be at the top level, but the order doesn't really matter. The next thing I'm going to do is my use effect. So can anyone tell me how do I do a use effect that runs once when the thing starts and it's going to call my pokey page?
Empty dependency array.
What?
Just the dependency array.
Yes. So if you want it to run just once, empty dependency array. Cool. Now, how do I call pokey page? I can go back to here to see that. Maybe Pokey API, right? So if I have my Pokey page and I say Pokemon slash, 72, that's going to return a Pokemon. So given this URL, can anyone tell me how I write the logic of the use effect to call that?
Use axios.get.
Yep, so I'll do axios.get. And in this case, I'm going to give it this URL. But I don't want to give it 72 every time. What do I want to give it?
ID.
ID, right. So it's going to be unique to the ID we pass in. And then what do I want to do in response?
Did you want to do
Pokey.
the image?
How about we will care about the image, but for now we're just going to do the dot then, and we're going to say, as long as we got something back, as long as we do the dot then, we'll get a response. And now I want to save that whole object to Pokey.
You set Pokey, and then you pass the response in.
Yeah, but by the nature of this response, it's actually going to be in something called data. So we'll say set Pokey response.data. And then maybe I'll print it at the end here, console.log Pokey, just so I can see it. And then maybe this would look something like, well, for now, we'll just do this.
I think
Does
we gotta
that dot
import
then
Axios,
have to
right?
be a function? Sorry.
What was that?
Someone else asked a question. They can go first.
No. I was just, do we have to import Axios for that to work?
Yeah, I did that for us.
Go ahead, Ethan, I'm sorry.
Sneaky quick.
Does that dot then have to be a function like you made it? I mean, in your example, you just use response. I mean, you did use an arrow function, but maybe it's just the way you wrote it.
You're saying in here somewhere?
Yeah, it's just the way you wrote it. Like, the arrow function looks different. Within the README.
Yeah,
I
I'm
can put
looking.
it in the chat.
Because I think I do that a little later, right? Where are we looking in the README?
I just posted what the arrow function looks like in the chat.
Okay. Right, so that would just be doing it in line. So that is correct that you could also do that. So like basically this is just a matter of JavaScript and arrow functions. First off, this part is optional. So whether I wrap that in parentheses or not, it doesn't matter if there's only one thing. A lot of people choose to do it anyways. And then the arrow, if I want it to be multiple lines and do multiple things, that arrow needs to be followed by curly brackets. If I want to do it all on one line, I could just do this.
Okay, thank you.
So that works just as well.
Can you rewrite that as like function, brackets, whatever? Just, regular JavaScript notation.
Yeah. So this is what that looks like. It's really, I mean, that's the part of programming that has to do with just style. Everyone's gonna have a different choice. My only hard and fast rule with style is if you do something one way, do it that way everywhere. So whatever pattern you like, try and stick to that pattern. So you're not just like, making it hard for someone else to read it because you're constantly changing your style.
Could you
Remember
do
to
that
look in
by
here.
specifying like function instead of using an arrow function?
Say that again.
Could you do that specifying like the standard function instead of using an arrow function? Like if you just put function and then the parentheses with the function name before it.
Yep,
then
that works
bracket.
too. Yep. I could have just said, like, you can also write an anonymous function like this. Yeah, that works as well.
Okay, thank you.
Yeah. And the difference between an anonymous regular function and an arrow function, there is a small difference that has to do with the this keyword, but as long as the this keyword is not involved, you're good. It won't be different. Right. So yeah, we printed this all out. And now from here, we might say, okay, each thing has a sprite and each thing has a sprite with front default. So maybe I'll do something like that. And you know what, actually, I want to know the Pokey's name too. So maybe up here, I would say like, well, actually, this is what it's going to look like. depending on which URL you go to, I would say something like first we'll do an H2 and it'll have pokey.name, right? And then there will be an image below it. And that image is going to be self-closing. Oops. And it's going to have a source equal to pokey.sprites. Was that it? Yeah. Dot front underscore default. And I imagine I'm going to have an issue here when I try and do this because a lot of it will work. So this works, but now I'm going to try and reload. It broke. Why did it break? Could anyone tell me? Seen some nulls. Cannot read property of null, reading name. Where do we think this came from?
You have the default set to null and it can't print the name of something that doesn't have a name.
Exactly, yeah, but null is kind of a good default, right? And that's what it's going to be at first. So how do we solve that problem?
Double ampersand.
Yeah, exactly. So I would do something like I would say, okay, within here, maybe I might say, let's open up some brackets. And I'll say, is there a pokey at all? If there is, do the next thing. If not, don't. I think it wants some curlies. Why doesn't it like that? It doesn't like that because it's more than one thing in there. So, sometimes you have to litter it with these. Yeah, okay. Now it's going to do some of the formatting for me. Now this should work as expected. I reload. It's fine the first time. Then we see tentacle. I go to 44. Gloom. Cool. Kingler. Gotta love Kingler. 110 was the last one, right? And now we try to go to 110.11. Now it breaks because we didn't write a dot catch. That's okay. Okay, so that's how we would use our parameterized routes.
Can you go back to your user page? Mine's not loading. I just wanted to see. If you scroll back up to the top?
You want to share your screen? Do we want to debug this in real time?
Yeah, sure. I might just be missing
that.
a small thing or something.
That could be useful. Debugging is at least 50% of programming, so.
Hey Ben, I just had a question. If you were to
Mhm.
pass in like /Pikachu, would that also work for ID?
Yeah, that's actually a really good point. So that ID, if we actually examined it, it's just a string. So it has no idea what you're passing in. It'll accept anything, including empty string, or white space. But it's just I'm just taking that string and plopping it in the URL. And because Poke API will support numbers or Pikachus, it'll work. So yeah.
Are you able to see everything?
Yep.
Whoops. Sorry.
That's right. You called yours user ID. Great. Now, what are we trying to see?
So the page doesn't load no more.
Right. So let's open our console because that's going to tell us some stuff. Go to console. Okay, so it sounds like I'm assuming go to user page. Your problem is that you're trying to import use state from the wrong thing.
Oh, am I?
Yeah.
Oh, it should be over there with use effect. Then.
Exactly. Yeah. So it's telling you the error, which is that there's nothing on. React Router DOM doesn't export something called use state. Let's try this.
Oh, there it is.
There it is.
Oh,
Now it's
but now
probably failing for another reason. Wonder what that reason is. Let's scroll all the way up. It's failing for the error we just saw, which is that use state starts out as null. But on that first render, it's trying to say, you know, pokey dot sprites, while pokey is null. So there needs to be a little guard there around that.
Oh, okay, that'd be the try catch or.
No, that would be take that like image element and just wrap it in braces and say, okay, is there a pokey? If there is a pokey, do this, you know, with the and. If there's not a pokey, don't do it.
Oh, okay, I gotcha.
Yep. So yeah, right there you could write it. Like just write,
Yeah.
you know, pokey and, not an if statement, not an if statement. It's got to be an expression. So pokey space and I think that should work. What's going on there? Line 16.
Yeah, user page 16.
Pokey was initially null, and then when this thing is coming back, I mean, pokey is eventually being set to something. Is it? Yeah, what's going on? Is user ID that's what you called it, right?
Yeah, so user ID should just be 44, I believe.
Yeah, can we look in your network tab? To everyone else, this is useful for you as well, because debugging is a lot of what you're going to be doing. So click on one of those to see some details and go to headers or something. At the same level, yeah. So you are making that called slash Pokemon slash 44. I'm not sure why it's failing. Click preview. What's coming back? Yeah, I'm not positive why it's failing. Can you go to that directly? Can you go to Pokey API slash 44? From your end, I would just copy paste the whole thing in there. So it was sending 44, right?
Yeah.
So I don't know why this wouldn't work. Hit enter. Is your own internet down by some chance? Maybe Pokey API is down. That would really mess up the assessment.
Yeah, no, I mean, it was just working for you. I don't think my internet's down.
Yeah,
I'm
it can't
talking
be.
to
You're
you through
talking.
it. Using the same one for this.
Yeah, I'm not positive why, but yeah, I'll check from my end. If I go back to my user page.
Oh, no, I found it right there. It's me and my it's right there. I had a .com instead of .co.
Oh,
So,
there you go. Yeah, that was it.
Yeah, that's my fingers moving faster than my brain.
Okay, so things should be working now. And let's just actually try out the thing that Della was talking about. Can you replace 44 with Pikachu and see what happens?
With Pikachu up here?
Yeah.
Or
up there, yeah. So replace 44 with Pikachu, if you can spell that right, yeah. Boom, it works, yeah. So that's pretty cool. That, you know, because that API works with both, it works.
Cool. All right, thank you.
Cool.
So parameters just handles that as both like, or like a non-type thing.
Well, parameters is going to treat everything like a string. You can
Okay.
change it after the point. You could grab what parameters gives you and then say treat it like a number. But in this case, whether it's a string with 44 or a string with Pikachu, that both of those work for us. Okay, so sharing my screen again. One thing I want to show us is use navigate. So use navigate is useful when we're in a specific situation as opposed to clicking a link and we want to re-navigate. So what if I had something like this where, okay, so first I'm going to come back to my user page and I'm going to grab another thing off of React Router DOM, which is use navigate. And the way I use it is similar to use params. I say const navigate is equal to use navigate parentheses, and navigate just returns us a function we can then call like this, navigate, you know, slash. You might be saying, why are we doing this? Why can't we just use navigate? That's because of that hook rule. It has to happen up here because if we try to call use navigate from inside of another hook or something like that, it wouldn't be happy. Okay, so navigate's going to allow us to do something like this, where I say, okay, here's my use effect. let's say I'm going to do Axios.get with ID, and then I do something in response. I'm going to bring this back to how it was. Well, this totally works. But what if I had that situation where I'm trying to get ID 11110, whatever it was, 1011. I'm getting a Pokemon that doesn't actually exist, right? I'm getting a number that's too high. Well, maybe we don't know about that number. We just want to say, okay, if you're ever in a situation where you got that error, right? So we're going to write a dot catch. So let's say this failed at some level. What I want to do is maybe first I'll say console.error, the error, but then I'll say navigate, which I got here from the use navigate. And I'll say navigate. Okay, what do we do in that case? Maybe in that case, we go to our error 404 page. Maybe we just go back to the home page. So in that case, I'll say, okay, send people back to the home page. That's what we do in that case. So now let's try this out. Come back here. Let's just go back to the home page to start. At the home page, I click user page. That brings me to Gloom 44. But let's say I actually went to, user too big. There is no Pokemon with this number. I go there. It tries to do it. It breaks, and then it navigated us back to the home page. So in reality, you probably want a better user experience that maybe tells the user something broke before redirecting them. But that's how that navigate works. It lets us, navigate programmatically as opposed to, only on a link. Totally lose track of the chat. I look at it. Cute baby Dennis. What are we talking about? Glad for cute baby Dennis. Okay.
You could put that in like a timeout, right? Put the 404, and then after 2 seconds, for example, redirect back to homepage, or 404 redirecting, something like that.
You put it. Oh yeah, absolutely. So I'm doing it in this dot catch way, but let's say I didn't. I could just have something random where it's like, okay, well, here's my use effect. Well, I probably want another use effect for this. You could have more than one use effect at the same time, just because what I'm going to put in the use effect is something that is done after a period of time. But I could say set timeout. And then in that set timeout callback function, it's going to happen after 4 seconds. And that's where I say navigate to, contact page, which was /contact. Okay, so now what's going to happen is this is going to happen. It's going to happen successfully probably, but after 4 seconds passes, this happens. Okay, so refresh, go to the user page. We see Gloom. We're going to wait. We're going to wait. We're going to wait. Boom, redirect. I guess I don't have something called contact. It's called contact us. But still, same thing applies. So I'm going to come back here and wait and wait and wait. Boom. So yeah, you can use that navigate like any function to redirect when you want to redirect.
Why did you take it out of the catch? Why not do the timeout inside the catch?
Oh, got it. I see what you're saying now. Yeah, that's reasonable. Can do that as well. So I'm going to go back to the dot catch case. So right, I could have a certain user experience where I would say something like I would set an error message. And then you can absolutely do that. Yeah, I could set an error message and then the user would see that error message immediately. And then I'd call the set timeout. So let's just do that because that sounds like a good user experience. I'm going to have something like error message and set error message, and it's going to start as empty. And I do have to account for it down here. So maybe in addition to if pokey do this, I'll say like, if pokey do this, but also I'll have something like, is there an error message? If there is, and only if there is, do I want you to say, this pre that says you done goofed. And that's not going to show initially, but if we get into this situation, I might say something like, instead of console.error, I think it's set error message, and error is going to have something on it called message. And because I do the set, that's going to happen right away. And then this just happens to use the same set, but this set timeout will do something after 2 seconds where let's say we go home. So we're going to see that logic now. Okay, we're going to go to our user page. That worked. Well, what if we went to 1,000, 10,000? We don't see anything. Now we see you done goofed, and then we go back to the home page. So yeah, that's a way to do that, and websites do that.
Awesome, thank you.
Cool.
It's like a redirect option, right? Is that, hey, 404 not found, redirect back to the home page.
Exactly, right. Cool. So we've covered a fair amount of stuff. There's kind of a lot in here, and I think there's one thing we didn't get to, which is somewhat important, and it's this use outlet context thing. So as you'll notice, if I'm in, let's say I'm at like app, oh, sorry, that's CSS. Let's say I'm in app, and app has this like outlet. And in this case, we're at the about page. So it's associated with the about page, right? Well, I might want to say, well, I want about page to get some information. I want to pass something as a prop, right? I want to say X equals 44. This will not work. Outlet's not going to respect props or pass them down to what replaces outlet. Instead, outlet uses something a little different, and it looks like this. So outlet can actually take a single prop called context, and these first brackets are to wrap it, and what's inside is an object. So just to see an example of it, I'll just say, okay, outlet takes a context. That context is going to be, I'm just giving it the value 44. How about that? What that means now is I can go to, let's say, my about page, and I would say, okay, the about page wants to rely on that context. How does it do that? Pretty similar to how do we use context otherwise, but we use a slightly different hook that comes from React Router, and it's called use outlet context. And that is going to allow your component to be aware of this context value. So I believe I do use outlet context just like that. It's going to return that value 44. So I'll call that num equal. And that's because of how I passed it. If I passed it an object, then I would want to like destructure the object, but I'm just passing it that value directly. The whole of the context is just this value 44. So I'm grabbing that num, and then I'll say about me num. And while this is a trivial example, that same pattern will allow you to pass any data, around, as long as if you're in the app, you'll have the outlet. As long as you can pass the context there, anything that replaces outlet will have access to the context. And now I'm going to go to about. There we go. It has it. Okay. So coming back to my docs here, this was what I was worried about, that there's a fair amount to teach here. And we're running out of time right now. We did cover everything we wanted to cover, including use outlet context, but we probably could use a little more time with that. So I'm definitely open to doing something at like 1:30, talk about this stuff a bit more if it would help people, introduce the assignment a little more. Over here, I have a section where we're just being more explicit about the client side versus server side thing, because this is always something that trips people up. So it's worth reading this. Just being explicit about if you type something into the URL browser, that's going to make a request to the server. If you click an A tag, that's going to make a request to the server. It's only this link tag, which is React Router aware, that will, stay client side. And these aren't exclusive. So it does get a little confusing, but, maybe you have a route, my website / contact, right? If someone were to go to your site / they'll get the entire React site. They'll then click a link maybe, and that goes to / contact. That happens client side. But if someone were to take that URL, my website / contact, and they were to put it in the URL bar and hit enter, that would make a server side request to that URL, which means On the server, you have to be able to handle all those URLs. You're just probably serving up the same React app. Yeah, we're going to do a little more after lunch because this one's big. I hear you, Jake. There's this final section called loaders, but I made it a bonus. Francisco thought I should include this because he likes it. It's basically a clever way of doing use effect type stuff with React routers. So you might notice that if I come back to my site, let's say I go to home, if I click on user page, I click on it, it goes right there. And then a second later, you see the info pop in, right? So that's not considered a incredible user experience. Rather, React Router allows us to do this thing where it says, I'm not going to navigate to that new page until I make the request and it comes back successfully. So by the time you navigate to this page, everything's already there. That's what a loader is. It's not really essential we know about it because you don't have to use it on the assignment. You don't have to use it on the assessment. But we can look at it for a second. Noah, to answer your question, it's not that React apps have to be single page applications, it's that they are single page applications. So if you're, when we say single page application, we just mean the fact that it's a very interactive website. If your question is, do React apps have to use client-side routing? No, they don't. But it tends to be a good fit for it, because if someone you wouldn't want to have, you could, but if you have multiple React apps representing different routes on your page, and that's all server side, you're probably just going to be you're going to be copy pasting a lot of common code, a lot of common HTML between them. Okay, so I think what we're going to do, actually, as long as everyone's good with it, we'll end at 12 and we're going to come back 1:30. 1:30 to 2 is when we're going to review the assignment a little and maybe cover some more of these things like use outlet context. The assignment is probably what you can guess. It's starting from the end of day 3. So it has the use state and the use effect stuff working, but we're going to want to basically split it up so that details panel is now details page and it's a separate thing. And most of that is just going to be about practicing this so that you can practice the setup, because setup is a big part of it. This is an example of that loader thing. Basically, we have this image loader. It's just a separate function. It's aware of the params. That makes the request, but we export it separately. And then in the router, that's actually where we say, okay, this user page, it actually relies on a loader. So if anyone would ever go, click on a link, user/82, it wouldn't go directly to the page. It would first call this loader function, get the data, and then go to user page. And then user page would be able to use another hook called use loader data, which just directly gives it whatever was returned from this function. So this is the end result, and it ends up being a kind of nice pattern because you can split your async request out into something like this. And then when you look at the component just assumes it has that. You don't have to handle like the data starts out as null case because you didn't even go to the page until the data was there. And if it errored out, you'd never go to the page at all. So yeah, I mean, we're running out of time. For the last 2 minutes, let's just take questions. Here's a React router. Oh, this is the tutorial React router provides for you. Like this is their official docs tutorial. They say it takes an hour. This is where I learned how to use it. There's, a lot of different cases you can care about. But yeah, let's just come back at 1:30, and 1:30 to 2, we're going to do some more of this. Just make sure we understand it. And then like the other days, I'll jump around to the different pairs because I believe we're pairing today and help with this. Are we pairing today? It is Thursday. And that means we are pairing today. Yeah. So I'll generate the pairs after this. Cool. Any questions before it is now 12 p.m.? So you're free to go, but any questions? Let me stop sharing for a moment. Stop recording.